Okay, we're on? We're on. Great. Okay, let's get to work. I do have some music on in the background, so if that is ruining the stream audio or something, I've never tried this before. Again, I'm not good at streaming. I don't do this very often. This is just really motivation for me to actually finish Advent of Code this year. So if this is fucking up the audio, let me know, please. Okay, let's get started. So I'm trying something new. I kind of redid my setup last night for this. So I now have a pretty different repo structure. So let's, I'm gonna touch source day6.rs. day6.rs. We're using the, this Advent of Code, Cargo Advent of Code. So we're gonna do cargo AOC input. And that should have downloaded the input. So if we go to input/2024, we can now see we have day6.txt. Okay, so let's take a look at the problem for this time. To get the problem, I'm going to do the other AOC CLI. To download. Okay, only the puzzle. Cool. So let's take a look at the puzzle. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype. Blah, blah, blah. Okay, so the input is map, and there's a guard at the little upward caret. Okay, the guard is facing up. Star. Okay, any obstructions are shown with the hash. So I already saw a little dumb meme of this on Reddit. It's like the Pokemon 2D RPGs with the sliding snow puzzles. I don't know if anyone here ever played that, but okay. Lab guards in 1518 follow strict protocol. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Okay, so the guard is going to move up, 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 hit this one, and then they will turn. And then we're going to move this way. And they're going to turn, they're going to move down. Yep, okay. The guard eventually leaves the mapped area. Okay, so here are all the places the guard will visit. The guard will visit 41 distinct positions on the map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? All right. Interesting. That's a fun one. Let's do it. So let's get a test set up. Let's test input. Okay, so I guess the first thing we need to do is parse this into a grid. So let's have a grid struct, and then we'll have a function to parse it. And then we're going to have something to solve given the grid. Going to take in the grid, and let's now put a count of steps. So here we can just do like grid equals parse test input, and then we can do So equals that Q1, the grid should be, I think it said 41. Yeah, 41 distinct positions. Okay, cool. Let's test this up. Cool. Okay, it compiles, just crashes in compile time, obviously. So this is a new library I'm using, the Cargo AOC library. So the way you do it is you have like a AOC generator for day 6. And then we're going to label this one just AOC day 6 part 1. And then we can try cargo AOC. Cool. And that'll run it all for us. Nice. Okay, so we have our tests, we have our actual answer ready to go. Let's implement the logic. So to get the grid, we're going to say the grid type grid is just going to be a vec of well, I kind of want to try something. I want to try laying it out in a 1D grid, like packing this into just an array. But I don't know. I have like a theory that might be better for performance, but let's not go too crazy trying to out-optimize the compiler. You know, the compiler, sure, like grids of grids require like another heap traversal, like heap pointer following, but I think that'll be fine. Like it's not gonna really affect performance much. We can save that for like improving on microbenching at the very end. Let's just do a normal same representation. So what are we going to store in this grid? We've got a couple of things. We can store whether there's an obstacle or not, right? So it'll be true if there's an obstacle. Okay, so we're going to parse this by saying input.lines.map, take a single line. In that line, we're going to split it into all of its characters. And we're going to take each character, and if the character is equal to the hash mark, then it's an obstacle. Then we'll collect that into a vec, and we'll collect that into a vec. Cool. So yeah, no fallibility here, no need for any unwraps. So let's just add a little test here. Let's just say assert that the grid len number of columns is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in each column, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then the grid. Cool. Okay. And you know what? I think we're probably going to want to have like utility methods on this. Let's make an actual struct. Cool. Okay. So, and let's store the width and the height, because I'm pretty sure we'll need that. So let's say the width, well, the height is the number of rows, and then the width here. Okay, cool. Why does it not know what we want anymore? That's funny, but whatever. Okay, and then here we can tell we want a vec using the turbofish syntax, which is how you tell Rust inline what generics you're trying to set. Okay, so now I can just say assert that grid dot height, grid dot width. Okay, let's see about that now. Interesting. Thinks I got the height wrong. Oh, you know what? Yeah, I did. I forgot about this row here. So that is totally my bad. Okay. Next up. Yeah, I wonder if there's any way for me to keep. Oh, it's fine, whatever. I really, one day I'll actually understand how streamers stream things nicely, but for now, I don't, and that's okay. Sorry, YouTube's telling me that the video resolution is not supported. I don't know, what happens if we just watch this in another tab? Just want to make sure this doesn't look like shit, you know? Seems fine to me, so whatever. Okay, back to work. So we're going to take our grid and our starting position. You know what? I've realized that we actually have to also track the guard's position here. So maybe the input should also have... Yeah, let's put a guard in here. The guard will be at a certain point. So now let's take all of this, and we're actually gonna do something different. We're gonna say if the guard is there, it must be occupied. So let's say that, like, let's check what the guard position should be. Let's have let mute guard equals none. If okay, no, that's not what we wanted. Here I want to say if character is equal to upwards, if the character is the guard, then the guard should be that point. Which means we're going to need to know what the position we're currently looking at is. So let's add some enumerate calls. We get the index. Guard is some x, y. And it is not an obstacle in that case. And then we can say guard equals guard.unwrap. Okay, now we have stored the guard position too. So now we can start solving it. So we're just going to track how many steps it takes for the guard to leave the boundaries. So let's start with just a dumb little for loop, and I'm sure we can replace with a nice iterator. Steps taken equals 0. So what is the condition? While I don't really want to mutate the grid. So maybe I'll break the guard into its own little property. Let's have the input actually be the grid and a point for the guard. So this now needs to take grid and a guard. Okay. That's not how we do it. Gotta do this. Okay, what's the complaint about now? Do we compile yet? I gotta say. Okay, now I compile again. So the parse is probably working. Let's just check with the guard. Make sure we parse the guard correctly. Guard should be equal to what? The guard is at 1, 2, 3, 4, 5, 6. Okay, YouTube is complaining that my resolution is bad, so let's just quickly tweak this. Trying to, oh my god, I think I've messed this all up, but whatever. How do we, okay, cool. Hopefully that looks better. Whatever, I don't know what I'm doing here. Okay. It's like, okay, whatever. It'll be fine. The guard is in 1, 2, 3, 4. Oh, okay, that's not how you do assert equals. Oh, and yep, we're using normal kind of X, Y, and Z, so 1, 2, 3, 4. Okay, cool. Test pass again. So now we can actually start solving it. So the condition is going to be that while we're going to need to make the guard mutable, this will just be steps taken eventually. So while the guard is in bounds, so while guard x is greater than maybe we should make the garden an unsigned. Maybe we should give the guard's position, let the guard's position be unsigned, so we don't have to worry about it like exceeding the boundaries. We can check if it's -1. Yeah, I like that. Let's change these to eye size. So the guard's x is greater than 0, and the guard's y is greater than 0. Or maybe we just need like an inbounds method. Let's take another point. It'll emit a return a bool. So let's just say that points x is positive, points y is positive. Points x should be less than the width. And the points y should be less than the height. Here we have to change the guard to be and what's here? Okay, yeah, we still haven't done this. Okay, still compiles. So while grid.is in bounds guard. What's wrong with this? It expected a tuple. Okay, well that's fine because it's a copy type. Cool. So while the guard is in bounds, we're gonna make the guard take a step. So first we have to check what way is the guard facing. So maybe the guard should also have a direction they're facing. And then maybe a guard should be woven up type. Struct guard is a position and a direction. And then we want this to return a guard. This should now take a guard. Okay. Cool. And down here we need to say guard dot position. Cool. So what else do we want to do here? We've got to okay, now we can just start solving it. So let's just say look at whatever is in front of the guard. So is Okay, so if the guard is looking up, we're gonna get, let's make a little method for if there's an obstacle somewhere. Where's our impl grid? So if it's in bounds, and we'll have something for if there's an obstacle there. Self.inner. So first we get the y. And then we get the x. Okay, and then we should probably have something to make the point move by direction. So where's our point type? We'll have up from, so impl dir, have a function called to, which takes in the current point and returns new point, and we'll just match self. If we're going up, then it'll be we'll just make car mutable. Then I'm just going to add 1 to car. Car dot car dot 1 minus equals 1. Car dot 1 plus equals 1. Car dot o minus equals 1. Car dot o plus equals 1. Okay, we've got nearly everything we need, I think. So let's see. So firstly, let's take a look at what's in front of the guard. Space in front of guard. This just becomes guard dot direction dot from guard position. What do we call this? 2, okay. So now we have a new point. And now we just need to check if the point's an obstacle. Okay. So then if they are facing, then we want to turn them. So let's add a new turn method to our direction. Returning, so if you were up, you're now going to be facing right. If you are right, you'll now be facing down. If you are down, you'll now be facing left. And if you are left, you will now be facing up. Okay. So now we're going to get to turn. So if guard is facing obstacle, then we're going to say the guard direction turns, and then they're going to march 1 step forwards. And this to method doesn't really make sense. We're kind of taking, like, you're going in this direction, starting from Okay. And then we took a step, so steps taken plus equals 1. Okay, let's see if this works. Got something out of bounds. That's interesting. I thought the bounds check was correct, but I guess not. Let's just debug, print out the guard. Now let's get a more concise debug for the guard. Okay, so the guard is eventually marching off to the right. So I guess our is in bounds check probably just has something off by 1. So our guard took more steps than he should have. Okay, well, let's see. How many steps does the guard take in the example? The guard moves up several times. Let's count. 1, 2, 3, 4, 5. Then she turns and takes 1, 2, 3, 4. So 1, 2, 3, 4, 5. Then she turns and takes 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then turns again, goes 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. Okay, interesting. I guess I shouldn't have just blindly put an off by 1, perhaps. Because the... Right, let me think real quick. My brain is apparently not on. Let's say the grid had width and height 3. This would be 00, 10, 20. So yeah, she would be in bounds as long as her x position was less than the width. So where exactly is... Oh, you know what? We aren't doing a bounds check for the obstacle. That's why. So when we do is obstacle, if the point is not in bounds, then there's an obstacle there. Oh, this needs greater than or equal, because 0 is totally a reasonable place. Okay. What's going wrong now? When equal to 0, then it's in bounds. It's only in bounds if it's less than 0. Let me just double check this by doing the opposite. Let's say if either index is less than 0, or if the x is greater than or equal to the width, or if the y is greater than or equal to the height. It should have made a difference if I got my bounds checking correctly. And we're going to grab this all. This is checking now if it's illegal. So now let's get this. So this is illegal if it's negative or if it's equal to the height. So then make it legal. Okay, so I feel confident now that I have my bounds checks correct. Okay, so what is it going wrong here? So it's saying that the last thing, I don't know, maybe I got some little detail wrong with like the obstacles maybe? Yeah, let's do a little sanity check and count the number of obstacles. 1, 2, 3, 4, 5, 6, 7, 8. So while we parse, let's count the number of obstacles. Got the number of obstacles right. Maybe we did something wrong with the turning. Up to right, right becomes down, down becomes left, left goes up. Okay, what about the stepping? Up is smaller, down is larger, left is smaller, right is larger. If you're out of bounds, there's no obstacle. Are we consistently indexing things correctly? I think so. Oh, you know what? We are overcounting. Yeah, that's the problem. We're overcounting these because we actually want to just check the... Like, if you take a step over... So we're not counting the number of steps that she takes. We're counting the number of distinct positions she visits. So that should be easy. We just need to keep a hash set or something. So let's say... mute. Positions visited, hash set from, we're going to put in just the current position. I'm going to use an fx hash set because it's faster. As hash set from okay, and then we're going to add her position here. Okay. But we shouldn't include the last place. So we can just do a -1 here because it'll include one invalid location. Okay. I think we're ready for the real thing. Let's try the CLI thing out. Cargo AOC. Well, I guess just run this thing. Okay, the answer, I think, is 5080 for my input. Let's see. That's the right answer. Okay, nice. Now we can get rid of these debug statements now. Ran pretty quickly, okay. Only took, like, less than 150, like 160 microseconds. That's pretty fast, I'd say. Okay, part 2. While the historians begin working around the guard's patrol route, you borrow the device. I guess I should show it in here. Okay. Returning after too large to safely search the lab. Adding a single new obstruction is okay. So I'm going to place an obstruction in such a way that the guard will get stuck in a loop. There are 6 different positions where new obstruction would cause the guard to get stuck in a loop. Okay, we have some illustrations. How many positions can you choose? Okay, cool. So I feel this should be pretty straightforward, actually. Let's copy this. Let's get part 2. So this time we're going to basically run a test and find the loops for every position in the grid. And I'm sure there's some kind of smart way to do this, but I think this should be totally fine. Just, you know, try every position and see if it supports, if it causes a loop. So we're just going to say for x in O until grid dot width, y in grid height, if grid with new obstacle with new obstacle. So pissed off by Rust Analyzer. With new obstacle dot, or maybe it's in Helix, I don't know. I'm going to set this inner point to have an obstacle, and then we're going to run it and see if loops the new grid and the old guard then okay. Okay, so now we just need to write this loops function to detect if there's a loop. So function loops, gonna take in a grid and a guard, return a bool. And this will be very similar. We're just gonna, grid is in reference to a grid, and the guard is a guard. Why does it not need to be mutable? Oh, grid doesn't implement clone. Okay. We're just gonna borrow it. And we could avoid the clone here. We could just mutate this one thing and then undo it later. So let's, yeah, why don't we just do that? I'm just going to say I don't know if this runner will let us mutate the input. Yeah. So we'll do one clone here. Let's say and then we'll say new grid update, new grid, and then we have to set this back to false after. So this way we don't have to keep cloning it in every loop. The guard doesn't have to be mutable, that's right, because we can just copy it every time. What's the problem here? We need to, rather than borrow the guard, we can just copy it and put it in here. Okay, so we want to keep the loop going. If they exit, then they didn't cause a loop. But if they ever try to visit something that's already in there, then they did cause a loop. So I think the insert returns a bool. So yeah, already visited. If already visited, return true because it caused a loop. Now I think there was something about you can't put one where the guard starts. Yeah, so diagrams, there's 6 new. Yeah, okay, can't put it in the guard's current position, so let's make sure we eliminate that from here. We'll just say if guard dot position is equal to xy, then we'll skip it. And we'll have to make these as eye size. Okay, let's try out this. Test Q2. Don't need these asserts anymore because we know we're passing these correctly. So let's check the Q2 returns 6. Interesting, we found 99 positions. I'm getting a lot of buzzes. It's just... Okay. Cool. So, because we're getting 99, I think it's just finding that every single position is valid. So why is that the case? Well, the first one we try, putting in the top left corner, we know that shouldn't work because the guard never visits that place. So I would like to know why that is working. So why don't we just firstly, let's only run the test we care about. And now we can put a little debug for the guard. I'm curious which cell makes this happen. God fucking damn it. Oh, whoops, that's not what I wanted. I wanted to put in the guard's position. Let's change this to only run once. It says the position she already visited 4-5. Maybe I just got this. Did I just get this wrong about when it returns true? Maybe it's the opposite of what I wanted. Oh, it returns whether the value was newly inserted. Yeah, okay, so this should actually be not. Cool. All right. Okay, it still thinks the answer is 41 things. And every time okay, I think I just misread the hash map again, the hash set again. If the set did not previously contain this value, true is returned. If the set already contained this value, false is returned. Well, I'm confused. It's like always giving me the same point. 4, 6. 4, 6, 4, 6, 4, 6, 4, 6. And that is the guard starting point, right? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6. Oh, because the guard already goes in a loop? Wait a second. I think we're supposed to use a different input for this. No, wait, what am I talking about? The guard can't always be going in a loop already, otherwise... Oh, you know what? The condition isn't that she visited the same position again, but she visited the same position going in the same direction. Okay. So instead of checking the positions visited, we have to actually store the position and her direction, which is just storing the whole guard. So that's straightforward enough. I have to implement equality for the guard then if we're going to store her in this set. And implement hash. Okay. Let's try this again. Now it thinks that there's only one way that can happen. When the guard loops back and is looking up. Okay, let's go back. Let's try a case we know should work. Like the one from the example. The one in the example, you put one next to the starting position, which would be x is 3, and the y is 6. Because normal one is 0, 1, 2, 3, 4, the same 6. Okay, so let's see, does this work? That does seem to work correctly. Okay, good. Here the guard should be going to Okay, let's try a different option from the examples. Let's see. Did I just do something stupid here? Let's just make sure this is actually looping. No, we know it has to be looping. Yeah, cool. So another example where it should work, given to us by the docs, option 2 is that we put a 1 in the position 0, 1, 2, 3, 4, 5, 6. And then 0, 1, 2, 3, 4, 5, 6, 7. Okay. So, interesting. Why is it even getting 1 at all? Like, how is this even advancing at all? Like, okay, guard started loop at 5, 6, at left. Oh, I know. I fucking knew that I was trying to be too smart over here. We're always setting this to be false, even if the grid was had an obstacle before. So really what we should be doing here, I think this is the problem, is we just need to, like, we should store the previous value, basically. New grid.inner yx, and then not to set it to false, because what if it was true before? And let's see if this is the right answer. No, it's not. It's too high. Okay, let's not try and be too smart. Let's get it right first. We can always make it faster later. Let's just say new grid equals. Well, let me try rereading the problem first. So I want to verify that okay, we know that the current set of obstacles isn't enough to make our loop. And we know that there is, so yeah, let me just make sure I didn't do a little silly logic error here. So new grid equals grid.clone, and then we're going to set this obstacle to be true. And we don't have to worry about resetting it anymore. Okay, so that didn't change anything. We're still overcounting. So 1938 is too high. We need the answer to be less than 1938. I guess we can skip anything where the obstacle's already been, where there's already an obstacle there, right? Because I can't possibly affect it. Let's make sure of that. Let's test our hypothesis. If grid dot is obstacle remove that line because it's making it take longer than it should. Okay, so correct, it still didn't make a difference. So new obstruction can't be placed at the guard's starting position. Yeah, I'm checking that. Yeah, I don't know what we're doing wrong here. These are all valid places, right? We're not putting an obstacle out of bounds. Let's just check. Yeah. Let's rerun this on the test input and just see what the make sure the 6 are correct. Okay, 'There's an obstacle at this thing causes a loop. We're gonna put in X, Y. Seven, 9. Seven, 7, I see in the examples. 6, 7. Yep. 3, 8. Oh, 1, 2, 3, 8, and 2, 8 as well. Or 1, 8, yep. Well, it looks like we're right for the input, for the test input. So what am I missing about the real input? How does the real input differ? Hmm. To place new obstruction. I'll get stuck in a loop. I don't know. Yeah, I really don't know what's going on here. I'm wondering if maybe I should just look up a hint. If I go to the Advent of Code subreddit, there's usually some kind of well, I don't know. And I gotta get to work, so I guess we didn't figure this one out yet. I'll come back to it later in the day. Thanks for watching all.